Hello everyone and welcome to this tutorial about engines. So there is no guide about engines for Rome to the War Remastered available. So I wanted to show how I do the engines for my Total War 1942 mod. So it could be useful for your mod and how to set up new engines. So first of all, let's check how engines are defined in the game files. So first of all, you have the description engines.txt, and well, let's have a look at the ballista entry here, and I will describe what each property means. So first of all, you have a type. This could be any name. Then you have the culture, so which culture will be using this. So for example, if you have a ballista that is used by both the Romans and the Greek, and you define the culture Greek here, then the Roman ballista will be different. So you can define a type here, ballista, with a different culture. Then you have the class, and this needs to be either one of the existing classes. So you have a ballista, you have an onager, and you have a heavy onager, and a scorpion, repeating ballista. Of course, you have the siege towers, the rams, etc. So you cannot define your own class here, and the game uses this. For this tutorial, I will be using ballista, but with custom skeleton. Uh, because in my case, I have an howitzer. This is the M5 howitzer, uh, and it could be used as onager, but for close range combat, the ballista class uh, will come in better than the onager, because onagers will stop firing when the unit is too close to it. So ballista keeps firing even when the unit is around here. So that's the reason why I always use the ballista class for my engines. So there you have the projectile, which is just a reference to a projectile in the desktop projectile file. I'm not sure if it's used, but just define the same as you have in your tester unit edu file. So let's go find my howitzer. So here we have the howitzer edu file. So as you can see, the secondary attribute, it's now firing a howitzer projectile. And if we go to my howitzer description, then you can see that is also firing a howitzer projectile. Alright, so let's go back to the ballista, because that's the base one you want to use most of the time. Then you have different engine model groups. So you have three states. So first is the normal, which is the alive engine. You have an engine skeleton, which is the skeleton defined in the Desker engine skeleton txt file. We will loop through that later, but this is the file which contains the animations and the sound events coupled to it. Then you have different lines here. So you have the engine collision. This is the quite a low poly cast file you have to create for your engine, and it should be less than 400 faces. Otherwise, the game will just, if you have a model with too more than 400 faces, it will just ignore every face afterwards. So be sure that this is a very low detail of your engine. Then you have the outline. Well, this is just like the collision box, just use the very low lot as well. You can even use the collision here. This is added, by the way, for the remastered. Then you have different model lines. So the first one is the highest detail of the LODs. If you have the game settings to ultra, the game will only use this one. Even when you have a distance larger than 120 meters, then the game will just use this one. For the other details, if you have a setting to medium, then certain lots will be shown. And if you have the settings to very low, then only the latest entry will be shown. So you have from highest to lowest detail the level of detail, the lots. And this number here defines how far away the camera should be away from the engine to show the next lots. But once again, if you have your gun run at ultra like me, then only the first entry will be used. But you always should create also different lots for the players that do not have high graphics. Alright, so next model group is the dying state. This is a unique entry because you can now move bones as well for this dying animation. So this is the animation that is shown when the ballista is dying. And then you have the dead group, which is just a cast with no bones. This is just a state, well, when it's dead. So it has no animations, no other stuff. It's just a mesh. I will show you how I create it in my tutorial. So next we have the engine radius. I will just ignore this one because I never use it. The engine radius is the radius on the x-axis. So when you have a model here, it's like this, the radius. Then you have the length, which is this, so the length of the engine, and this is used for the collision box. Then you have the width and the height, and the engine mass. I'm not sure why this is used, but probably to push away others. So if you have an engine that is with the higher mass, probably it would push away the engine with the lowest mass. Alright, so then we have the engine dock distance. This is the radius in meters around your engine that will trigger the dock. So when a unit left the engine and it comes in that radius, it will pick up the engine and start firing again. Then we have the mob distance. Not sure what that means. Probably this is the range for when the reserve units of your group will be behind the engine. So if this is very low, then all the units will stand around the engine. But if you have high, then the units will be the reserve units will stand away further away from the engine. Well, next you have the engine flammable attribute here, which means that if you set it to true, then the engine can be set on fire. And this is the ignition time and the fire effects. I just keep it to all the same as the ballista. Then you have these entries, and I asked this, and this basically means the collision as you have for buildings around the engine, that units will be moving around this. So this could be a drop, an ellipse, or a rectangle. This will be drawn in the game around your engine, and then the units will move around that collision. Next you have this entry, and not sure what this means. Then you have the push points. So you should at least have one push points. This is a trigger for the unit that pushes the engine, and will be relative to the root bone. You have the same with the station. So this is the position the unit will be when the engine is cranking and loading and firing. So you have crank position and captain position. This is all relative to the scene root bone. Next you have the engine health. well, if engines fire at each other, the damage of the projectile will be used for destroying it. So if you have a highly armored target, well, you can set this very high, then the engine will need more hits from boulders or projectiles to destroy it. Next is the missile model. I'm not sure this is used, so I just ignore it. Just you need one line, not just use the same projectile as defined above. Then you have the missile pods. So this is the position when the projectile spawns relative to the bone root. I will show you how to calculate that as well. Then you have some other attributes I'm not sure is being used. So let's first go to my howitzer. So I have already copied the ballista and created some well, default entries. So I called it the M5 howitzer here. This is type, it's a ballista class, and it has a projectile of howitzer. So first let's go to the engine skeleton. So basically you have the model in 3ds Max, and you can create bones whatever you like. I think there's a maximum number of bones for engines, but for modding I only need 3 bones because I do not need a cranking bone. So you want as much bones as you need for animating the engine itself. So in this case I have the bone root, which should always be %, and inside that I have a frame, which is this object here. It's skinned to the frame. I have a barrel, so this is the gun itself. And the shield, which is this object here. And then we have the wheels. So you need to call the wheel bones, bone wheel, and then double underscore, and then left, and same for the right. So the game will use this to rotate the wheels itself. You don't need to animate the wheels. So first, let's finish this object here. As you can see, the wheel bones are not correctly aligned, so let's finish that. So first delete the skin modifier and isolate the wheels. Alright. Let's use wireframe override. So you want your bone to be exactly in the middle. Otherwise the wheel will also rotate a bit around the bone. So for wheels, you surely want the bone to be exactly in the middle of the wheel. Alright, so this is the starting point. And now do the same for the left wheel. As you can see, this one's quite off, so let's move it a bit. Alright, and isolation. Let's save it and assign the skin to the right bone. Bone wheel right. Same for the left wheel. Right. So now we need to export this as the COLLADA file and convert it with IWTE. I'm using my own script here, so I have COLLADA multi export, so it will create the lower lots automatically. So let's make the lowest amount of vertices for the optimizer 50, because it's a quite low lot by itself, as you can see. hit the export button. Alright, so we have the latest version here for my engines, and I call it M5 howitzer. Alright. So we're here now in the IWTE. Let me fire up the program. Alright. So let's first check if the 3ds Max, yes, it created those 4 lots. Let's remove the others now. You don't need to convert them again. Alright, so let's use the directory conversion engine, and I always have a done folder. Alright, so we now have the M5 howitzer lot here, and it's targeting the M5. So we copy these cache files and place them inside the models engine folder, howitzer, and we have an M5 here. Let's delete this one, we don't need it. And let's go to, well, we have different lots now. So we have the highest lot, lot 1, lot 2, and lot 3. Let's make this lowercase as well, and let's make this aligned. Alright, so because I copied this from my OG mod, I need to enter the, let's check where this, the outline line. And what position is it? After collision. So now we need to make a very low lot for the collision and the outline. So I will call it M5 howitzer collision, and I will use the same for the outline. It could be the same. So first let's open, let's say first, let's open the COLLADA file for the 1825 and check how we did that. Well, it's not here. Alright, so let's just take it from the engines. So we have collision cache here. Go to cache to directory. Alright, so we have engines. Done. Alright, so let's open that COLLADA file. Make sure that you used openCOLLADA plugin. So as you can see, this is just a very low lot. I actually have a little bit too much polygons here, but let's open our howitzer. And we can use multi-res or Pro Optimizer. Let's make a simple one. Be sure to always have copies of different stuff. So we have an M5 howitzer collision. So we keep the original. So let's have a box like this. Let's rotate, move. It's a little bit too high, so decrease the height a bit. Alright, so let's duplicate this one. Wheels are quite low poly, right? So it should be okay. Let's create a box here for the middle parts. And a box for the gun. Let's create a low poly wheel as well. 10 sides. Alright, so we have this and this. Let's assign a texture to it. And a skin modifier. Bone. Roots. Export. And 5 howitzer collision. Let's convert it to CAS. Alright, so if a problem with the CAS. Alright. It should be an armature. Not in the bone roots. Great, done. So we now have the collision, which is quite a small file here. Alright, done. So next up, we have the model, we have the collision. Now let's create unique animations. And for that, IWTE has a very nice tool. So first, you want to have a task. If you're using ballista as a reference, so you have all the ballista bones, you could create a task. Let me check. Like this. So we have an animation task. Well, this is data cast, by the way. I need to all the way around. Ballista animations. So this is a task file. So first of all, you have the task ID, which needs to be cast to Collada. Then you have the cache file, the input file. So that's while we're looking at this task, let's create one for myself. So this is a complete task. Let's call it. Be sure you have the task here, because otherwise it won't be registered. M5 howitzer. This is the wrong one. This is the input one. Complete. Alright. So what do we have here? We have the input cache file. So in this case, we want to use the directory for the model. So we have model engines. Well, we can use this one as well. We can just create it. So we copy this directory, paste it here, and we have the howitzer lot 0. So this is the input model file. Then we have the output. So I'll just make sure the output will be howitzer. So this is directory. Then we have the file name out. So we call this M5 complete animations. We don't want to create the same task as we have here. Then we have the task file full path out. So we want to use this. Data cast. And it will create a task like this. But we want to create it ourselves, so complete. Alright, so this is the output task file. We need to convert it back. So next we have all the animations of the engines we want to copy into our model and want to animate it ourselves. So for ballista, if you use a ballista skeleton, just use the ballista as the example here. So I use it for my OG Rome, but you can also use the remaster animations. And all of these animations will be put into your model and will be keyframed after each other. So it will be pasted in one big animation and you can then convert it back. I will show that in a second. So when we run this task, I already have it for the default ballista. We get this. So we have ballista model, and as you can see, it will just first use the ballista idle, the idle to move, then the moving. So it creates an output task file, which is in this case ballista anims. So here you can see at what frames the different animations stop. So first we have the ballista idle, which is frame 1, 2, 3. So this is just an idle animation, 1, 2, 3. This is when the engine is idle. Then we have a ballista idle to move, which is from 4 to 14. So the animation goes up. And that's, by the way, make sure your custom frame rate is be set to 20. That's what the game uses. Alright, so then we have the moving from 15 to 31. So as you can see, the engine is moving, but the wheels are not rotating, and the position of the bone root is the same. The game will handle that by itself. So only use the rotations of position of the bones, like some minor movements like jumping around. Next we have the move to idle. So this is just 32 to 42. It's just getting back to idle, so after it's complete, moving. Then we have stand to crank. So this is when we have an idle engine and the handlers are getting to it and starting to idle. So for a vanilla ballista, you will see this. It will only rotate this bone. And then we have a loop, the ballista crank. So this is a loop where we can see the handles, the cranking handles rotating, and we see these the sinews getting closer. So it's well, this is just a cranking animation. This is quite a big one. Then we have the fire idle. This is when the engine is ready to fire, but it's waiting for something. This is just quite low. And then we have the fire commence. So this is when the engine is in this state. So this is exactly the animation. From this point, the projectile will be shot from here and will be fired. Then we have the recover. So this is the animation for the engine after firing. Started here and then done. Right, so in my case, I have an extra one, which is the dying animation. So let's have a look at 8025. I have an extra animation, which is be helpful because I can use the same bones. I recommend using the same bones for every animation type. The game could use more bones, for example the dying animation, but it's a lot easier to use the same bones, bone counts and bone names for every animation type because it's quite easier to animate it. So first we have our animations here. So we have the moving to idle. This is the aiming of the gun. Then we have the fire animation. This is the idle. And here we have the commence. So from this point it shoots the projectile. For the shooting and you have wheels you want to rotate, you need to animate the wheels here manually. The game will not rotate the wheels for that point. Alright. So for engines you don't need to only use the rotation mechanic of the bones. You can also position the bones. So in this case, as you can see, this bone here, the barrel is when after firing, it's getting a little bit inside as a recoil, and you can basically position the bones as you want. And this is quite useful for the dying animations. So when you have a look at the last animation, the dying one, I put it at the end. You then have this. So this is how my 8025 is dying. As you can see, all the bones can be moved independently, whatever you want. And there we go. This is dying animation. And from this point, you have the dead mesh. So this is the entry we saw here in the Desker engines, and the dead. So now the ballista or engine is dead, and it has a mesh with no bones. So we want to create that after we exported the animations. So as you can see, this is the 8025, and I'm using the same bones for my M5 howitzer. So I can use that animation. So let's get back to this task. So I already have the howitzer animations here. So I have the idle to move, moving, move to idle, stand to crank. By the way, extra, extra, extra. So now we run this task. Let's see what IWTE is giving us. Alright, so we have engines, cache to day M5 howitzer. We have a problem, which is division by 0. That's interesting. Bone barrel incorrect versus bone barrel. Bone barrel incorrect versus bone barrel. Well, that's interesting. That's something that's new in the current dates. So we do it differently. Alright. So first, let's save this as animations, M5 howitzer, anims. Let's make it complete because I always have the dying. Let's open the 8025 and I have 293 frames. Let's set it here. Length is 293. Now let's get back to, well, of course, when IWTE does work, and it will create one COLLADA file you can import, and then we have all the animations. You can then modify it so that your engine has unique animations, because, well, the position of the bones is different in this model than in the 8025, so the bones will be offset and the model will be weird in that case. Can I show that somehow? Let me check. So let's run another instance of this one. Let's run the task, the new directory. See if we get the same exception here. Done. Alright, so it's a problem with IWTE. So let's open that COLLADA file. We set in guess anim howitzer M5 complete animations. So this is the model, but with the positions of the 8025. So when we import it, the frame is off, the shield is off. It's not how we have. So it will run the same animations, as you can see. And it will override it, so let's make it 20 frames per second. Length is 293. Alright, that's better. 293, please. Yes. So let's give it a view. So here you can see that the positions of the bones is off because it's used as the 8025 skeleton. But you can, in 3ds Max, of course, you can position the bones and it will be adjusted for each frame as long as you keep the auto key off. If you have auto key set to on, then you need to animate it for each frame. But for example, when I choose the barrel and I set it like this, and a little bit to the left, then it will be just for each frame and it's better. So let's save this as the complete anims. Then open the M5 howitzer and let's check the original positions. So this is the frame. Let's copy it. Frame equals x, y, z, 0, 9, minus. Alright, so that's the offset for the frame. Then we have the barrel, which has this offset, y offset, same I guess, yes, a little bit, and the z offset. Next we have the shield, zero, and C. So we can copy this animations in our keyframes. So wheel left, X, Y, C, and the right wheel is a little bit of copy and paste work, but at least that's better than doing it by scratch. Right, so you need to make sure that every bones are the same for the animations, otherwise it won't work. So in this case I have an 8025 skeleton which has these bones, and for this model I use the same amount of bones and the same position of the bones, and I can reuse that. So let's open the animations again, and we have the bone roots, which is the default, bone frame, minus 109, and 528 is the same. Barrel is different, so move, move, move. Nice. Shield, 0, Nice. Bone wheel left. Seems off to me. Not sure what's wrong with this, but well, it doesn't really matter as long as it's aligned with the axis. So let's isolate this with the bones. Wireframe overrides. Same with the other bone. Because the model animations are not used, the bones in the model, it's the animations file what we are creating now, which is the best and is calculating the positions of each wheel. So let's end isolate, and boom, we have our model here. It's a little bit too wide, so let's move the wheel a bit closer. Same for the other. The part of the axis we won't see anyway. Alright. A little bit more like this. It's alright. So let's play the animations and see how it is now. So it goes. So it's now aiming, firing, wheels animating, rotating, and it's dying. So as you can see now, this is a dead animation. It's quite off. The gun is under the ground. When we look at this, the shield is under the ground. So we have to change that. The bone barrel. So we enable auto key. We'll delete this and these frames, and we now go to the latest frame. And we check. Alright, it should be rotated. And be moved a bit like this. And the wheels not floating in the air. This wheel is. So we will do the same for this wheel. So we delete these keys. And so from this point, this is the latest animation. We also delete this key. Sounds good to me. The frame looks decent. The shields, it's from this point onwards. Let's animate it ourselves. Rotate it. Maybe move it a bit. So now the gun is clipping, the barrel is clipping with the shield. So let's change that. So the wall gun is visible. Alright, so that's about it for the animation part. So we save it, we export it, and let's make it howitzer, complete anims. Alright, so now let's go back to the task. Which one is this? This C. A. Task, engines. Do we have an howitzer here? Yes. So there we go. We go to the location of the file. So we have M5 complete. Yes, correct. Directory out from the. So we change all these names to M5 howitzer. So we have the keyframes. So we set this to full. This is the mesh that will be created by the game. So that's 5. Call it this an M5 mesh. Overlap frames, no. And we have the latest keyframe is the howitzer of dying. So which is this? Let's run. Let's call task, select task file, IWTE tasks. So we have M5 howitzer. Done. Alright, so let's have a check. So now the game of the IWTE creates all these animations. Most important is to check if your idle animation converted the double underscore to a space, because otherwise your wheels won't rotate. So be sure that you have in the CAS file bone wheels right. You cannot edit it yourself, so be sure you have double underscore in the when you export it. So that seems about it. Let's copy these animations to data animations engines. Howitzer. Boom. So here we have all the animations for the engine. Now let's have a check in Desker engines claddens. So we have 8025 somewhere. Right. So this is the howitzer. It's called howitzer cannon. We have idle, attack, recover. It's just the same as this. But this is using the ballista. So let's copy the 8025. And we name it M5 howitzer cannon. And this is the dying animation, M5 dying. Oh, it's already there. So we have howitzer, and let's edit all of this. M5 howitzer. And same here. So after each animation we have these events. So for example, we have the howitzer reload, the howitzer recover, and the howitzer fire. These are located in the it's an EVT file, and it has a reference. Oh wait, this is not what I want. Let's open it with Notepad. So it just is a trigger to the MISC sound database called NM Howitzer Fire. You need to do this in the remaster format because it's different in the original. So be sure you have the remaster format. And this is just called to the MISC sound bank. So it could be anything you want. So yeah, you can just leave gaps here if you do not want any sound triggers. So now we have the M5 howitzer cannon. Let's go back to the engine. So the new engine skeleton for the normal state is the howitzer. Then we have the M5 howitzer dying, which is the dying animation. And now we go to, oh, by the way, let's give it a good lot with the same bones. So in this case we use the second lot. Now we go to the dead. So a dead model. Well, the dead model could be anything as long as it has no bones. So let's call it dead. So to do that easily, we save these animations and we call this M5 howitzer destroyed. We then select the meshes, we convert it to editable mesh, and we then delete all bones. So it won't have any animations now, and it's just a static mesh with just these properties. What I want to do is, that's not something I talked about before, but for dead texture, so we have an M5. So let's talk about the textures. So this is the M5 default TGA. The game also needs a normal map file, which you can generate. Be sure it's in the right format. It has a black. You can use the Intel TextureWorks in Photoshop. and be sure you select normal map. You can create a preset and you can set it to normal map and normalize, and that will delete the blue channel, which is nice. We have an, as you can see here, I did not do that for this one, so let's do normalize it here. That saves performance for normal maps. Alright, so next we have the roughness map. So this is the roughness. If you have a totally white spot, then it's a rough object. The more black you add, the less rough it will be. So if you have metals, you want more like a gray texture for that. So for example, this star here is darker gray than the surrounding area, so it will be less shiny. That's not really necessary in this case, but well, that's how it is now. Let's do not change that. Then we have the metallic map. So the metallic map shows if you have metals, you want it to be lighter, and non-metals you want it to be black. So for example, in the default file you see the tires here, but I do not want tires to be metal because it's no metal, so I make it black. In this case you see this symbol here will be very shiny, so we can show that in a second. But now for the destroyed, I want this texture, and I make it a crash, a default. Alright. So I have this crash style, which is something I created. I can boom, and then use multiply. So now as you can see, it looks like a bit burnt down texture. So we save this as the crash. We then assign these objects to the new texture. So we have M5 crash. I do not want to need normal maps for this one because it's just a crash object. So it don't need to be shiny or anything. And we export this as M5 howitzer destroyed. Bam. So let's open IWTE and use the method again, convert it to CAS. Done. Let's check the results. So engines done, and we have the CAS file here. Let's check if the texture is correct. So we have 8025 crash. Oh, it's the 8025. M5 destroyed. It's still assigned to 8025 crash. Interesting. That's not what we want, so let's open this back again. Oh, that's because we failed. Alright. Export again. Destroyed. Convert. Engines to done. Now it uses the correct texture. Alright, so we copy this here, place it in our models engines folder. So destroyed, copy the name. And let's get back to the engines. So we have the collision here, we have the destroyed. Alright, so that's the howitzer. So we have the model complete, we have the animations complete, and we have the destroyed animation of the destroyed model, the mesh. Let's get back to the default. So we have the model here. Let's use a great tool of mine, the Rome.war tools. And we have engines, call collate engines props using a box. Well, let's draw a box. So we have a box around the engines. The height 1, 2. Alright, so this will be the height. Now let's calculate engine props, and then we get this nice tool. Engine radius and height. It will calculate the length, it will calculate the width and the height and the radius, etc. automatically, so that's nice. Next, we have this tip. I will just ignore this for now. Push points. Alright. You can change that later, but for this tutorial it's quite long already, so let's go to the missile pass. So we open up the animation. So, oh, this is the 1825. We go to the point where it starts firing. So, boom, this. So this is the point where the projectile should be fired. So we create a sphere like this. So this is the pass. Align it with the gun. A bit smaller. And then we use get projectile offsets. The armature is fine. Boom, done. So now it's about time to test this engine in game. So let's check first if this is actually used. It is. So let's open up the game. Let's regenerate the manifest because we added some new files. And let's quickly check the M5 howitzer. So we added a few so we can check the dying animations as well. So we will be fighting against the 80-25 pounder. Sounds fine.
Units! Await my orders!
So we have the model here, and you can see that all bones are positioned at the right position, so we know that the animations are working.
Units!
To be sure, let's check if the wheels are rotating.
Forward!
So let's move them a bit forward. Well, the wheels are also working.
Units!
Right, stop.
Halt!
Let's fire projectile and see
Fire at
if
will!
that works. And let's also check where the projectile will be fired from. Well, it's a little bit off to the bottom, so we can change that later. Alright, so now let's
Halt!
stop. And we want to check if the dying animations are also working. So that's the enemy. Well, it works for the enemy, but let's let them fire at us. Alright. Right, so this one is dying now. So, well, it turns to the lowest lot in this case. So,
We're being attacked!
and this is the dead mesh. Alright, so that's all working. That's fine. So you can, if something is off, you can change that later in the animations and proceed. And everything should be fine.
Unit! Unit, General!
Alright, so that's it about the tutorial. Thank you very much for watching. Perhaps I will create a manuscript about it, so a tutorial guide about the files you want to open. Yeah, well, if you have questions, don't hesitate to ask me, and I'll see you next time.